All right, today we are going to start the process of learning about piecewise functions. We're only going to do beginning steps today, and eventually we'll kind of build on until we're doing um, a complete piecewise function. All we're going to do today is graph one function, but we're going to put a restriction on it. So this is the function that we're going to graph. And you'll notice that there was a comma here. It's kind of blocked now by my pink line, but there was a comma there. The stuff that comes after the comma, that's the restriction. So there's kind of like two parts to this. So what we're going to do is we're going to graph the function first in its entirety, and then we'll focus on the restriction. Okay, so f of x equals x plus 4 is our function. That hopefully reminds you of mx plus b. And if we have x plus 4, that means that our y-intercept is 4. So we would start at 4 on the y-axis. And then the slope is the thing in front of the x, which is technically a 1 here. So if my slope is a 1, I can put it over 1. And then remember, the top is your up or down. And since that's a positive one, we're going up 1. And then the bottom number is how far we're going to go over. And since it's positive, we're going to the right. So from 4, we're going to go up 1 over 1, up 1 over 1. Okay, and now I would recommend that you graph the entire line all the way as much as will fit on the graph. Because what you don't know yet is what the restriction is going to look like. So you need to continue the line in the opposite direction as well by going down 1 over 1 and get that line to fill up the entire graph. Some of you guys, when you graph, you only graph just like a little tiny portion, but I want to make sure that you're graphing the whole line here. Okay, so here's my line. So the pink part is done, and now what we're going to do is the restriction part. All right, now the restriction is going to be well, this x less than -2, that represents a vertical line. And that vertical line is going to kind of act as like an invisible fence or a barrier. And this vertical line is at -2. So I'm going to put a dashed vertical line at -2. And that is my barrier. And since it's a less than symbol, that means that I only want stuff to the left of that barrier, less than, to the left. Because it was a less than. So what that means is I only want the pink line to the left of this barrier, which means I do not want any of this stuff here. So all of that is actually going to get erased. I would do your homework in pencil, not in pen, so that you can do this kind of erasing. Okay, and then what we have now is we've got a barrier and we've got our function, which is a line, but we only want it to the left of our barrier. And then what we also have to pay attention to is whether this is a less than or equal to or just a less than. Since it's just a less than, we're going to have an open circle. If it was, I'll do it over here. If it was a less than or equal to, we would have a closed circle. But since it's just a less than, we're going to have an open circle. So what I mean by that is where it would hit the barrier is right here, See this point, -2, 2, right here? That's where it would hit the barrier, but we need to have an open circle there because it cannot actually hit the barrier. It has to stay strictly less than or to the left of the barrier. So that would mean that like we could get really close to this electric fence but not actually touch it. Okay, so we have a line, a function, and then we have this restriction that restricted us to having to stay to the left of this invisible line. And since it was just a less than, we have to have an open circle, which means we cannot actually touch this line. Sometimes you will be able to touch the line if it's like a less than or equal to, or a greater than or equal to. If it isn't or equal to, then it's going to be a closed circle, and then you would be able to touch the line. All right, let's try another one. Okay, so everything that comes before the comma, that's your function. So here's our function. And then the restriction is the stuff that comes after the comma. So this right here is the restriction. Okay, and then the pink is our function. Now, looking at that, I see absolute value, which means that the shape of this function is going to be a V shape. And I know it's going to be opening up because the number out in front is positive. Okay, so let's review how to graph an absolute value. We start with a vertex. Okay, the number on the inside of the absolute value, we take the opposite of that. So I see a -2, but we want the opposite, which is a +2. And then this number on the outside, I keep as is, +1. So my vertex is at 2, 1. It's right there. And then the slope, it's not really a slope, but we kind of talk about it as a slope, is a 3. That's the number out in front here. Technically, you can put that over 1. The top is telling us whether we're going up or down. Since it's a +3, we're going up 3. This is a +1, so we're going to be going over 1. But in order to make a V shape, we have to go over in both directions. So from our vertex, I have to go up 1, 2, 3, over 1, up 1, 2, 3, over 1, up 1, 2, 3, over 1. And then I go back to my vertex, and I go up 3 the other direction 1 in order to make it a V shape. So this is an absolute value function, not a line. So it should look like a V. All right, so draw in your V, and again, I would plot enough points to where it takes up the whole graph. And now we're going to look at our restriction. So we're going to draw a vertical line at 3. So here's 3 on the x-axis. We're drawing our vertical line. Okay, and we have a less than or equal to, which means we need to stay to the left of that vertical line. And because it has the or equal to part, it's going to be a closed dot wherever it would hit the line. So I only want the pink graph to the left of this blue line. So that means I'm going to erase anything that's to the right of the blue line. Okay? Now, because it can equal, that means it can hit the fence. It can touch the fence. So this right here will be a filled in circle. Maybe I'll make it pink. Okay, so that is a filled in circle. It's a V shape and it stops right there where it hits the line, and it can touch the line, so it's a closed dot. Okay, so we're graphing pieces of functions right now. Let's try another one. All right, so anything that comes before the comma, that's your function. So that's what we're going to graph. And then anything after the comma, that's your restriction. Okay, so here's our function, f of x equals 2. Now, sometimes if this f of x is bothering you, you could Think of it as a y, like y equals 2. And this should look a little weird. It does not have an absolute value, so it's not a V. It does not have anything squared, so it's not a U shape. This is a line, and this is a special kind of line. Got to remember back when we first learned about this, whenever you have y equals just a number, that's a horizontal line. So we are dealing with a horizontal line at 2. So 2 on the y-axis is right here, and we're going to have a horizontal line there at 2. Whoops. Okay, now we're going to put in the restriction. So it's a vertical line. Our restrictions are always vertical lines at -3. So here's -3. We're going to put a vertical line there. That's our barrier. And I have a greater than symbol, which means I'm going to need to stay to the right. Greater than, this vertical line is to the right. And since it's just a greater than symbol, I need to have an open circle where it would hit the barrier. So I need my pink function to stay to the right of this blue barrier. So I'm going to erase everything over here. Okay. And so my function is staying to the right of my barrier. Wherever it would hit the barrier needs to be an open circle. So there should be an open circle at -3, 2. Right here is an open circle. So it can get really close to the barrier, but it cannot actually touch it. It cannot actually equal it. All right, let's try another one. Everything before the comma, that's your function. Everything after the comma, that's your restriction. So I'm going to start by graphing my function. Now when I look at this, this is a line, just like mx plus b. So if I rewrite it here, 2 is the y-intercept. So that's where you start on the y-axis. And then -2/3 is the slope. So the top number is negative, which is telling me to go down. And then the bottom number is positive, which is telling me to go right. So from my y-intercept, I'm going down 2, over to the right 3. Down 2, over to the right 3. Down 2, over to the right 3. Now I would go off the graph this way, but I could go the other direction to fill up my graph. So that would mean going up 2 and to the left 3. And I want you to do this, I want you to fill in as much of the graph as possible because you never know where that restriction is going to be placed. All right, so there's our line. Now we're going to put in the restriction. So again, the restriction is a vertical line at 0. So here's 0 on the x-axis. So there's going to be this barrier right here. And since it's a greater than or equal to, I need to be greater than this blue line, which means we need to be to the right. And since it's a or equal to, that means it's going to be a filled in circle. So I only want stuff to the right of the blue line. I do not want any of this pink stuff. Okay, so I only want to keep stuff to the right of the blue line, and wherever it hits this barrier, I need it to be a closed circle. So right here is where it hits the barrier. That's where the closed circle would go. I'm just going to make it pink like it was, but kind of overemphasize it. So I know that you intended for it to be closed. Okay, so it's all about graphing a function and then picking where your restriction is, where your barrier is, and then deciding whether it's going to stay to the right or to the left of that. Greater than means you go to the right. If it has a or equal to, that means it's going to be a closed dot. So going back here, greater than means we're going to the right, but there's no or equal to symbol, so it's an open dot. where it would hit that barrier. Less than or equal to means you're going to stay to the left of the barrier. Since it has an equal to, we're going to have a closed dot where it would hit the barrier. This one was a less than, so we stay to the left of the barrier, but it did not have an or equal to, so it's an open circle. Here's that open circle where it would hit the barrier. So we're graphing pieces of functions, pieces of lines, pieces of absolute values. There's going to be a restriction or a barrier. You're going to keep your function either to the left of that barrier or to the right of the barrier. And then pay attention to whether you should have closed dots or open dots. Okay? All right, that is it for today. There's more to this, but that's it for today. Have a good one.